All right, so solve by completing the square. Let's say we had x squared minus 6x plus 7 equals 0. So x squared minus 6x plus 7 equals 0. All right, so based on stuff we've already done, how are you going to complete this? How are you going to solve this quadratic equation by completing the square? What do you do first? You got to get that. You got to get all the variables one side, constants to the other. So we're going to move the 7 to the other side. So I get x squared minus 6x, leave some space, and that's going to equal a negative 7, right? Okay, so then let's make that an 8. Let's make that 8 right here. So we're going to move it over, become a negative 8. Make that an 8. All right, now for us, the coefficient of x squared is going to be 1, but at some point I'll do one where it's not 1, just to show you what to do. But if the coefficient of the leading term, the x squared term, was something like 2, you would divide everything by 2, because you need this to be a 1. And for us, it will be a 1. So when you complete the square, you need this coefficient of x squared to be a 1, and it is. All right, once you bring the constant over, what's the next step? You take the coefficient of x. What's the coefficient of x? Negative 6. What do I do to it? Divide by 2. Whatever that is, I'm going to do what to that? Square it. So what's negative 6 divided by 2? Negative 3. 3 squared is 9. Notice I put negative 3 in parentheses, and that's 9. What do I do with that 9?
You plug it into both.
You add it. Okay, you got to say add it to both sides. You add to both sides. So remember, what you do to one side, you do to the other. And so I get, now remember, if you're doing this correctly, the left side, this trinomial, shall now be what's called a perfect square trinomial. All right, which means I can write it as a binomial squared. So what do you think is that binomial? How are you going to factor this? What is this factored? X minus 3 squared. And that's going to equal what? 1. All right, so that's where we're at. Okay, so now, what property am I going to use next to get x by itself to solve for x?
Square root.
The square root property. Okay, good. So I'm going to go ahead and rewrite this over. Now, you do have the square root property in your test today, so keep that in mind. All right, so what's the next thing? Take the square root of both sides. Now, remember, you do the square root of both sides, you need that plus or minus, right? All right, so the square and the square root don't do each other here, so you get x minus 3 equals plus or minus, and then the square root of 1. You've got to see if you can simplify the square root of 1. Can I simplify the square root of 1?
Yeah.
Yes, what is the square root of 1? 1. So that means I'm going to end up with what kind of solutions? Rational or irrational?
Rational.
You know it's not going to be imaginary, right? It would be imaginary if I were taking the square root of a negative number. All right. Now, since this one here is a perfect square, that means when I take the square root of it, I get a whole number. So that means that my solution is going to be rational. So since it's rational, solutions are rational. Since it's rational, remember, I expect you to go ahead and split it apart and tell me what those rational solutions are. So you can say x minus 3 equals a positive 1, x minus 3 equals a negative 1. Add 3 to both sides. So what's one of your solutions?
4.
4. Add 3 to both sides. What's the other solution?
2.
2. All right. Okay, so that was a quick review and complete the square. We're going to need it in a little while when we do circles. Okay, so let's look at this one now. All right, what is the equation of a circle? The standard form of the equation of a circle. Okay, so what happened to the roll? When you sign it, can you put it back right here, please? Thank you. What's the standard form of the equation of a circle? X minus h squared plus y minus k squared equals r squared, right? Okay. So remember, this is the standard form of the equation of a circle, where h and k represent what? The center. So the center is hk. And remember, h and k you get when you rewrite it in your mind as x minus h and then y minus k. So based on what we talked about last class period, suppose I had this equation. Let's suppose I had x plus 5 squared plus y minus 2 squared equal, let's say, 16. First of all, you got to recognize that's the equation of a circle, not a quadratic equation. That's the equation of a circle. It's not quadratic because if I were to multiply these binomials out, this would be an x squared, and this would also be a what? A y what? Squared. So that would be a circle instead. A quadratic, the only variable that's being squared is the x. Y is being raised to the first power. So that's not quadratic, that's a circle. What is the center of the circle? Is it 5, negative 2? Is it negative 5, positive 2? Is it negative 5, negative 2? What is it?
Negative 5, positive 2.
Negative 5, positive 2. So notice that quite a few of you that got this correctly right off the bat without me explaining it. All right, so that's pretty good. So notice, though, you remember, some people seem to think that this right here is your h. It is not. It doesn't say x plus h. What does it say? X minus h. So you got to remember that this x plus 5 right here can be rewritten as x minus a negative 5. And so this is your h. Remember, x minus h. X minus h. And that's already right here, y minus k, right? So that means that k is what? No. 2. K is 2, not negative 2. 2. So your center is negative 5, comma 2. That's an easy thing to mess up on. And if you mess up, it's because you really don't know what the equation of a circle is, what it really is, or what the center represents in terms of the equation of a circle. So before you take test 2, make sure you understand this, because you don't want to lose these points. These are easy points to get. Now, what is the radius? Is the radius 16?
4.
Radius is 4. Remember, this right here represents what part of this equation?
R squared.
R squared. So R squared is supposed to be equal to what? 16. Well, how do you get R by itself? Square root. So if I square root both sides, I get R equals the square root of 16, which is 4. So your radius is 4. All right, and when you graph this, and you're going to have to graph it on that worksheet, but when you graph it, you got the center first, and what's the center in this case?
Negative 5, 2.
Negative 5, 2. So I'm going to plot that point. Negative 5, 2 is in the second quadrant. And from that center, I'm going to go, and the radius is 4, so I'm going to go 4 units to the right, 4 units up, 4 units down, 4 units to the left, and all that, right? So you go 4 units to the right, 1, 2, 3, 4. So there's a point on the circle. I go 4 units up, 1, 2, 3, 4. So there's another point. I go 4 units to the left, 1, 2, 3, 4. And I go 4 units down, 1, 2, 3, 4. And then you just draw your circle, just like this. So you use those points to help you draw a circle that has radius 4 and that center as being negative 5, 2. All right, now one of the other things you have to do in that worksheet, which you did last semester in Math 99, is find the domain and range. So remember, the domain is a set of x coordinates, and your range is a set of y coordinates. Now remember, how many points are on this circle?
2.
How many? You're saying, well, first of all, the center is not a point on the circle. A center just represents an attribute of a circle. When you graph a line, what was it that you were doing when you were graphing a line? You were graphing the solutions, right? And how many solutions did the line have? An infinite number. How many solutions, how many points are on this circle? An infinite number. You may say 4, because you saw me doing these 4 points here, right? But when I did this, what is it I was drawing, guys? I was drawing that every point that makes this equation, I can find it right here, a true statement. So all these points are solutions to this circle. So how many solutions does this circle have? An infinite number. Just like we drew the line. So whenever you graph something, you're graphing the solutions of that equation. So I want to find the domain. So I want to find, if I look at all these points right here, if I look at all these points, remember the domain is a set of x coordinates. And when you write the domain and range, you always go from smallest to largest. So if you look at all these points, remember a point represents an x and a y coordinate. What is the smallest x coordinate that's on these points?
1 to 11.
What is it? You can't see it?
-9.
-9. Okay, -9, right? Right here. In that -9 right here? What is the largest? Is this, if I look at this point right here, is that x coordinate the largest x coordinate? No. What about this point? Is that the largest x coordinate? No. That x coordinate that I'm pointing to is what x coordinate? I don't want to mess this thing up. It's -5. That's a -5 right here. If I look at this point right here, what is this x coordinate? -4. Is that the largest x coordinate? No. Where is that largest x coordinate? Right here, isn't it? What is that x coordinate? -1. So when we did it last semester, and we looked at the domain, we went across the x-axis and we asked ourselves, where do we start touching the graph? I start touching the graph when x is what? -9, all the way to what x coordinate? -1. Okay, and so the domain would be bracket -9, comma, all the way to what? -1 with the bracket. And then you do the same thing with the range. The range is a set of y coordinates. So if I look at this y coordinate right here, this point, is that the smallest y coordinate? Is that the largest y coordinate? Yes or no? No. What do you think is the smallest y coordinate? Where is it located? Right here, isn't it? What's that? What is that y coordinate though? -2. Is this the largest? Does this point right here represent the largest y coordinate? No. Is this one the largest y coordinate? Where is it? Right here. That is the largest y coordinate. What's that largest y coordinate? 6. So when we do domain, we go from along the y-axis like this, and where do I start touching the graph when y is what? -2, all the way to y equal what? 6. So the range would be bracket -2 to 6. Now, when we get into chapter 2, 2.1, you're going to notice that some of these are going to be parentheses instead of brackets. Now you're going to get parentheses if there's a hole in the graph. We're going to talk about that probably next week. A hole in the graph. So that's where the domain and range are now going to have parentheses instead of brackets. Notice that all these are solutions, right? So all these are part of the graph. So that's why we use brackets. When we get into chapter 2, 2.1, actually, that's where we're going to start looking at open circles, which are going to be parentheses in that case. So we'll have that discussion later. All right, so then we talked about this. Write the equation of a circle. Write the equation of a circle with center -8, 2, and radius is the square root of 7. Write the equation of a circle with center -8, 2, and radius square root of 7. All right, so you want to write the equation of a circle. What's the formula for the equation of a circle?
K squared plus
So x minus h squared plus y minus k squared equal r squared, right? All right. So to write the equation of a circle, you got to know two things. You got to know the center and the radius. Do I know both?
Yeah.
Yes. What is what is the center here?
-8, 2.
So what does the -8 represent? H. What does the k represent? 2. And the radius is square root of 7. And so I just plug in. I plug in, and right now I have this. I have in parentheses x minus h. And what's h?
-8.
-8. What do I do to that? Square it. Plus y minus k. What's k?
2.
2 squared equal r. And what's r? Square root of 7. What do I do to that? Square it. Now that's where I'm at. Now you don't leave your answer like this. You're gonna be very upset with me. Because I expect you to know several things. I expect you to know that x subtracted -7 is the same thing as what? I'm sorry, I meant x subtracted -8 is the same thing as what? X plus 8. Square it, and then y minus 2, leave it like that. And I expect you to tell me that the square root of 7 times itself is what? 7. So there's your answer. Okay? All right, and then out of curiosity, suppose I had this. Suppose I asked you, determine the center and radius of this. And let's suppose I had x plus 5 squared plus y squared equal, let's say 18. All right, so determine the center and the radius of this. Okay, so remember the center is HK, right? Can you tell me what H is of the center?
-5.
-5, because we had the discussion earlier when we did this one right here. I guess I should use a different number because I already used x plus 5 here. But this is x minus -5, right? So that's your H. So my center is -5, comma. Now this is y squared. So if you need to, you can think of y squared as what binomial squared? Y what?
0.
Y minus 0, right? So what is k?
0.
0. So what's your center? -5, 0. All right, let's talk about the radius. How do I find the radius?
Square.
The square root of what?
18.
18, correct?
Yeah.
Square root of 18. But the directions will say simplify the radicals. So besides the number 1, is there a perfect square that goes into 18? 9. So I can rewrite the square root of 18 as the square root of 9 times 2.
Yeah.
And what's the square root of 9?
3.
3, so I get 3 square root of 2. So that's your radius. All right, and then on your calculator, on the worksheet, they're asking you to round to 2 decimal places. So just what some students do is they'll put this in your calculator, but you got to be careful when you put 3 square root of 2 in your calculator. Make sure you put it in correctly. So hopefully you brought your calculator because you need your test today. But 3 square root of 2, I use this one right here. That is approximately 4.24.
Yeah.
This should also be what?
4.2.
The same thing, because that's supposed to be equivalent. So on your calculator, if you do square root of 18, you get 4.24. Okay, now the new stuff. Let's suppose I had this. All right, listen carefully to this. Suppose I had x squared plus 6x plus y squared plus 8x equal, let's say, 5. All right, go ahead and write this down. Now, is this a quadratic equation? No, it is not a quadratic equation. Why is this not a quadratic equation? What makes it not quadratic? I have an x squared, but what makes it not quadratic?
You got y squared?
I have y squared. If this were quadratic, the y should have what exponent? 1. And also, I did mess this up. This should be a y right here. I'm going to make this a y. So that should be 8y, not 8x. All right, now, can you from here tell me what the center is? Good. No, you cannot. There's no way you can tell me the center. So then the other question becomes this. Is the radius the square root of 5? You may think so, but it's not. Why is it you can't determine the center?
Because x and y squared.
Because you don't have it in this form. Does this right here look anything like this? No. So what I've got to do is this. Now listen carefully. What I got to do is I've got to rewrite the x's, the x terms, the terms that have x's, into something that looks like a binomial squared. And I've got to do the same thing with the y's, into something that looks like a binomial squared. Equal, and then some number. So I've got to make this look like this. And that's where completing the square comes in. So we're going to complete the square on the x's, on the x terms, and the y terms. So complete the square on the x terms and the y terms. Okay, so here we go. So what I would do is this. Go ahead and do this. Put the x's together. Put the x's together. X squared plus 6x, leave some space. You remember when I did the solving the quadratic equation earlier, right here, using completing the square? I said leave some space, right? Okay, so leave some space. And then plus, and then do the same thing here. Y squared plus 8y, leave some space, equal 5. All right, let's complete the square on the x's, just like we did with solving the quadratic equation. So forget that the y's are here. Just look at this. If this right here were my quadratic equation, see this right here? Just like the one we did earlier. How do I complete the square on this? I take the coefficient of x, which is what? 6. What do I do to it? Divided by 2. So 6 divided by 2, what do I do to that? Square it. Well, what is 6 divided by 2? And what's 3 squared? So I add 9 to both sides, just like this. Just like you did when we reviewed solving the quadratic equation by factoring. If I'm doing this correctly, this right here should now be a binomial square. It should be a perfect square trinomial, and it is. What is that squared now?
X plus 3.
X plus 3. So I have my h now. What's my h?
3.
No,
Oh,
negative 3. X minus h. Remember that? Okay. Now let's do the y's now. Let's do the y's. How do you complete the square on the y's? What do you do? Take the coefficient of y, which is 8. And I do what to it? Divide it by 2. And then whatever that is, I square it. So that's be what? 4 squared, which is 16. What do I do to 16? Add it to both sides. What you do one side, you do the other. If I'm doing this correctly, make sure you put the plus symbol right here. Just right here. So this right here should now be a binomial squared. What is it?
Y plus 4.
Y plus 4 squared. Equal, and then you add up all these numbers. So what's on your calculator? What's 5 plus 9 plus 16?
30.
30? And now you can tell me the center. What's the center? Negative 3,
Negative 4.
negative 4, and the radius is
Square root of
square root of 30. Is there a perfect square other than one that goes into 30? No. So you're done. Okay? All right, let's look at this one. So this is number 1. All right, let's do number 2. Suppose number 2, my equation of the circle looks like this. X squared plus y squared minus 10x plus 6y, let's do 12y. 12y equal, let's say, negative 7. Now remember, this right here is called the standard form, right here. That's called the standard form. When it's written like this, where it's written a bunch of terms like this, that's just called the general form. General form. Okay, but if you're going to determine the center of the radius, you first of all have to transform this equation into what form? Standard form. Which involves us having to complete the square on the x's and then complete the square on the y's. Before we complete the squares, what's the difference between the way I wrote number 2 and the way I wrote number 1? Yeah, number 1, the x's are already together, right? And here the y's are already together. Here they're not, so you got to put them together. So first of all, write this as x squared what? Minus 10x, and then what? Plus y squared plus 12y equal negative 7. All right, now let's go ahead and complete the square on the x's. What's the steps? Take the coefficient of x. What's the coefficient of x? Negative 10, not 10, negative 10. What do I do to it? Divide by 2. Whatever that is, I do what? Square. What is negative 2 divided by 10? And what's negative 5 squared? All right, so I'm going to add 25 to both sides, right? Okay, let me go ahead and leave some space for the y's. So I'm going to say negative 7 plus 25. All right, now if I did this correctly, this right here should now be a perfect square trinomial, which means I can factor it. And when I factor it, it's the same two binomials, or the binomial squared. What is it?
X minus 5.
X minus 5 squared. Now let's do the y's. What's the process?
Take the coefficient.
Take the coefficient of y, which is 12, divide by,
Two.
no? Okay, divide by 2, whatever it is, that's squared, right? So that's 6 squared, which is 36. So I add 36 to both sides, right? So now, don't forget the plus symbol. Don't forget to rewrite, say plus right here. Now this should be a perfect square trinomial, which means I can factor it as a binomial times itself. What is that binomial?
X plus
Y plus, not y minus, y plus, right? Because the 12 is what sign? Positive. If you put y minus 6 and you were to FOIL it out, that would be y squared minus 12y. But what did I want? Plus 12y. Okay. Now, when you calculate, what's all this right here? Negative 7 plus 25 plus 36. 68? Okay, so that's where I'm at. So now, what's the center?
5, negative 6.
5, negative 6. Good. The radius is the square root of 68. Huh? Oh, 64? I am just writing whatever Trey told me, which I should not have, right? He said 68. It's 64?
It's 54.
54. Okay, thank you. Trey, use your calculator, dude. All right, 54, right? Y'all said 54, right?
Yeah.
Okay. Now, right, it's a negative 7, so you got to be careful. It's not a positive 7, it's a negative 7. What is there, besides the number 1, is there a perfect square that goes into 54? 9 times what?
9 times 6.
9 times 6?
Yeah.
Okay. So I can write this as 9 times 6, right? And what's the square root of 9?
3.
So that's 3 square root of 6?
Yeah.
So your radius is 3 square root of 6. Now, if you let the square root of 54, you get most of your points, but you wouldn't get all of it because you didn't follow the directions. What was the directions? Simplify the radical. Okay, let's do one more with this. All right, number 3. Suppose we had this in number 3. All right, suppose I had x squared plus y squared minus 8x plus 4 equal 0. All right, you're going to see something like this. What's going to cause you some grief at the beginning?
That,
The fact you don't have a what?
Y.
A y term. You have a y squared. You don't have a y. That's okay. We can deal with that. All right, so let's go ahead and put all the x's together, put all the y's together, and notice you, just like when we complete the square on solving a quadratic equation, you had to bring all the rows one side and what on the other?
The Y.
A constant. So what is it that I've got to do over here with this 4? Bring it to the other side. Okay, so x squared minus 8x, leave some space, plus y squared equal negative 4. All right, let's complete this the square on the x's. What do I need to do to get to rewriting this as a something squared? Take the coefficient of x, which is
Negative 8.
-8, divide by 2, and then square. So that's -4 squared, which is 16. So I'm going to add 16 to both sides, right?
Yeah.
So now this right here should be a perfect square trinomial. So what's that binomial squared?
X minus 4.
X minus 4. All right. Now here I need to write this as a binomial squared as well, right? But I know what that is. Y squared is what?
Y.
Y
Minus 0.
minus 0. So y squared is just y minus 0, isn't it? Y minus 0 is y squared is y squared. And what's -4 plus 16?
12.
12. So now you know your center. What's my center?
4, 0.
4, 0. So I only had to complete the square how many times here? Once. In the other two, I had to complete the square how many times? Twice. All right, so the center's 4, 0. What's the radius? Square root of 12. But I can simplify that. What perfect square goes into 12?
4.
4. So 4 times 3. So it'll be 2 squared root of 3. Okay, all right. So that was complete the square with the circle. Okay, now let's look at this. All right. Still dealing with circles, we're going to shift gears a little, and we're going to look at this. Suppose I am given suppose we're told this, that, okay, determine the equation of the circle. Determine the equation of the circle given the endpoints of a diameter of the circle. So determine the equation of the circle given the endpoints of the diameter of the circle. Now remember, in order to determine the equation of a circle, what is it you've got to know? The center and the radius. Those are the two things you must know. I don't know any of that information here. Look, so here are my endpoints. My endpoints are 4, -1, and 6, 7. Those are my endpoints. Okay, those are the endpoints. All right, I'm going to draw that circle. I'm going to draw the circle, and so this particular diameter of the circle has these endpoints. So I have 4, -1. 4 -1's right here. So that's one of my end points. And my other endpoint is 6, 7. So 6, 7 right here. Okay? And I'm going to do the best I can with drawing this circle. I am going to be off with it. This is not a very good one. I did a very poor job with it. All right, but it's going to give you the idea of what you need to do. So remember, those are endpoints of what segment? The diameter, right? Okay, so I'm going to draw the diameter right here. All right, again, it's not a very good circle that I've drawn, but that's the diameter. So the coordinates of this point are 4, -1, and the coordinates of this point are 6, 7. So if I'm going to find the equation of the circle, what is it I've got to know? The center, which I don't, and the radius, right? There's no way you can look at this, and by the way, the diameter goes, and how many diameters are there on a circle? An infinite number. All these are diameters, right? What do you remember about the diameters, though? All these are diameters. What do you remember about the diameters? No, they're not the same, because these are different diameters. Okay, half of it will be the radius. That's true. But come on, what do you notice about these things I'm drawing? They all go through the center of the circle, right? So the diameters must go through the center of the circle. So I'm going to ask you this. If I were to draw this circle right here, and I do this right here, is this a diameter? No, that's not a diameter of the circle. Even though these are segments with end points, this is not the diameter, because the diameter does not go through this diameter does not go through the what? The center. A diameter must go through the center. You may remember from high school geometry, this right here is called a chord. A chord, C-H-O-R-D. That's a chord. This is a chord as well, but a chord is a segment whose endpoints lie in the circle. That's what a chord is. This is a chord as well, but it's a diameter because it has the what? The center. The center. Don't use the word midpoint because this chord has a midpoint, right?
No.
But is that midpoint right here the center of the circle? No. This chord has a midpoint, and the midpoint happens to be the center of the circle. All right, so the point is this. The diameter always goes to the what? The center. All right, now, how can I find the center? How can I find the center using this diameter right here? Find the midpoint. One of the worksheets, you had to find the midpoint, right? You find the midpoint. So to find the center, use the midpoint formula to find the center. And remember, what is the midpoint formula? X2 plus X1. So you add your X's together and do what to it? Divide by 2, and you add your Y's together and then divide by 2. And again, it helps if you label these. Let's call this X1, Y1. This will be X2, Y2. All right, so let's find the center. So the center is going to be the midpoint of this segment, this diameter. So I'm going to say, so the center will be 4 plus what? 6 divided by 2, comma, -1 plus what? 7 divided by 2. And then simplify this. What's 4 plus 6?
5.
So I get 5 halves, right? What's -1 plus 7?
Oh, wait, no, 4 plus 6 is 10.
10. 10. So I get 10 halves, which is what? 5. Okay. What's -1 plus 7? 6. And what's 6 divided by 2? 3. So I get 5, 3, right? Okay. So I found my center. What's the only thing else I've got to do? Find the radius. Okay, so let's talk about how to find the radius. So you know now how to find the center given the diameter. Use the midpoint formula. Let's talk about finding the radius. What do you remember about the radius if you're given the diameter?
Half of
The radius is half the length of this diameter, right? So how do you think you can find the length of one of these radii? Use the distance formula. So if I can find the distance of this diameter, then all I do is take half of it, right? So the radius will equal 1/2 of the diameter. 1/2 of the diameter. So what I got to do now is find the length of the diameter. Find the length of the diameter. So to find the radius, we need to find the length of the diameter. Find length of the diameter. So the center is pretty easy to find. It's just the midpoint of the diameter. The radius, you got to do a couple of things. You got to first of all find the length of the diameter using the what formula? Distance formula. So remember what the distance formula is? The square root of x2 minus x1 squared plus y2 minus y1 squared. The square root of that. And so I've already labeled these x1, y1, x2, y2. So let's go ahead and plug it in. You plug first and then you chug. All right. What is x2?
6.
6. Subtract x1. What's x1? 4. Whatever that is, I'm going to do what to it? Squared. Plus. What's y2? 7. Subtract y1. What's y1? -1. Whatever that is, I'm going to square. Okay? All right. Square root of. What's 6 subtract 4? 2. So I'm going to get 2 squared, right? Okay, writing that step. If you can do it in your head, that's fine. But if you mess up, it helps if you write it out. Because if you in your head, sometimes you'll mess up. What's 7 subtract a -1? 8. Good. 8. So that's 8 what? Squared. All right. What's the square root? What's 2 squared?
4.
So I got 4 plus, and what's 8 squared?
64.
So that's the square root of what?
28.
68. So the diameter is the square root of 68, right? So the diameter is the square root of 68. When I write it like this, I mean the length of the diameter. Now don't simplify this like we did in the other ones. Leave it alone for right now. Don't waste your time simplifying this. Okay? Don't waste your time. Leave it like that. Now the radius. If the diameter has this length, how do you find the radius? Divided by 2. So the radius will be the square root of 68 divided by what? 2. Don't make the mistake and say 2 into 68 is 34. Because that is not 68. It is not 68 divided by 2. That is 34, right? Is this 68 the same as this numerator?
Yeah.
No. This is 68. This is what? Square root of 68. Those are not the same number. All right, so don't make a mistake and say that's the square root of 32. It is wrong to say square root of 32. Don't make that mistake. All right. I mean 34. It's wrong to say square root of 34. Okay, so that's your radius, right? All right, now let's go back. We have enough information now. We have enough information now to go back and write the equation of a circle. What's the formula for the equation of a circle?
X.
X minus h squared plus y minus k squared equal what? R squared. So what is h? 5, right? What is k? 3. So what's going to be my equation right here, this part? X minus what? 5 squared plus y minus 3 squared equal. All right, now let's actually write this out. What is my radius? Square root of 68 divided by 2. What do I do to that, though? Square it. Okay, now don't leave your answer like this. I expect you to tell me that the square root of 68 divided by 2 squared means the square root of 68 divided by 2 times itself. What's the square root of 68 times the square root of 68? 68. What's 2 times 2? 4. Now simplify that. Is 68 divided by 4 a whole number? Yeah, what is it, 17? So now you have your answer. Your answer then will be x minus 5 squared plus y minus 3 squared equal what? 17. That's your answer. So it's a lot of work for that problem. Now, so that will be on test 2. And you're going to have a worksheet on that, so I'll give you that today. All right, let's do one more with this. All right, suppose that number 2, let's suppose that the endpoints are -8, 4, and I'm trying to make sure the center. Well, it's okay. It's fine if I don't. And let's say the other point is 1, comma, -10. So those are the endpoints of the diameter of a circle. So those are the endpoints of the diameter of a circle. All right. So if I'm going to write the equation of a circle, what two things must I know? The center and the radius. Which one's the easiest to find? Which one's the easiest to find with this information? The center. Let's find the center first. So the center, remember, is the midpoint of the diameter, right? So we go directly and use the midpoint formula. But let's go ahead and label these x1, y1, x2, y2. All right, so the center, remember you add your x coordinates together and divide by 2. So it's -8 plus what? 1 divided by 2. 4 plus what? -10, all that divided by 2. What's -8 plus 1? So I get -7/2, right? Okay, leave it as a fraction. Comma, what's 4 plus the -10? And what's -6 divided by 2? -3. So there's my center. So my center is HK. So H is -7/2, and then K is -3. All right. Now, the only thing I've got to find now is the radius. How do I find the radius? What's the first thing I got to do? Find the length of the diameter using the distance formula. So remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So I get the square root of, in parentheses, what's x2? 1. Subtract a -8, whatever it is, I square it, plus y2. What's y2? -10. Subtract y1, which is 4, whatever it is, I square. Okay? Now we're going to start chugging. What's 1 subtract a -8? 9. 9 squared. Plus, what's a -10 subtract 4? Negative what? 14. Good. -14 squared. Equal. We all know that 9 squared is 81. All right. On your calculator, what's a -14 times itself? 190 what? 196. Now, someone says that's correct, right? Okay. All right. And then 81 plus 196 is what? 277. All right. Leave it like that. Because you don't want to simplify that, because at the end you have to divide it by 2, and then you have to do what to that? Square it. You have to square it at the end. All right, so I found the diameter. Now let's find the radius. So the radius now is what? Square root of 277, all divided by 2. All right, we're almost done. What's the formula for the equation of a circle in standard form?
X minus H
Squared
squared
plus y minus k squared equal r squared. I know HK now. What's H and K? Negative 7 halves and negative 3. So it becomes X minus H. What's H? Negative 7 halves right here. And K is negative 3. So negative 7 halves squared plus Y minus K. What's K? Negative 3 squared equal R. What's R? What's the radius? Square root of 277 divided by 2. And I'm going to square that, right? Okay. Now, let's talk about the answer. Are you going to leave it as x minus the negative 7 halves? No, you're going to say x what? Plus 7 halves squared. Plus, and then y what? Plus 3 squared equal. Now let's go off to the side and figure this part out. Do the square root of 277 divided by 2 times itself. What's 277 times, I'm sorry, what's the square root of 277 times the square root of 277? 277. Divided by what though?
2.
2 times 2 is 4. 2 times 2 is 4. And that's, and you can't reduce it. So leave as a fraction. You know you can't reduce it because one's even, the other one's what? Odd, right? Okay. So 277 divided by 4. So there's your answer. Okay, that's all you do. All right, so let me go ahead and give you the worksheet dealing with this.